Quadratics. A quadratic is an expression in the form ax squared plus bx plus c. A, b, and c are constants, i.e. just numbers. So they're not variables, so unlike x, they can't just take any value in a given set. It's just one number all the time. And a cannot equal 0. Because if a were to equal 0, then this whole thing would become 0, because anything times 0 is 0, and you'd just be left with bx plus c, which is a linear function. So, yeah, and that would imply that you got to have the variable squared in the expression. And also, you can't have like a cubed in there. The highest power will be 2. Can't go higher than that. So what will that look like on a graph? Well, it could look like this. It could look like this. This is U-shaped. And this is where A is positive. And this is N-shaped, where A is negative. These two shapes are parabolas, and they are symmetrical. And the intersection of that mirror line and the graph is a vertex. Plural vertices. And we will look into finding the coordinates of that vertex very soon. But going back to this ax squared plus bx plus c, what actually do these things do? The c is the easiest one. This is the y-intercept. And what it does, so that would imply it literally just shifts the graph up or down. What A does actually, A enlarges the graph from the y-intercept, with the center y-intercept. And that's by a factor of 1 over A. And B does something a bit more interesting. Say we take this graph, which is sum ax squared plus c, because that is the y-axis there. And we just imagine this, which is negative a squared plus c. And if we start adding b terms, what we'll get is something like this. It'll have the same y-intercept, but the vertex will have been traced along the reflection. So, and the interesting thing is if you increase b, you trace the vertex along reflection to the left. And if you decrease b, trace to the right. So in essence, A enlarges and shrinks. B, I guess it does affect the horizontal translation, and C is only affects the vertical position.